Can you hear me clearly? Just give a response in chat box. Okay. Now we are in okay. Now the new concept is the third application of Bose model, that is energy of an electron. Energy of an electron. Energy of an electron. They have given direct formula. These derivations all will come in physics. Try to understand this one. Let the total energy of electron, let the total energy of an electron, total energy of an electron, total energy of an electron be E. It is sum of the kinetic and potential energy. It is sum of the kinetic and potential energy. Kinetic and potential energy. Kinetic and potential energy. That means here the total energy E equal to kinetic energy plus potential energy. Kinetic energy plus potential energy. And here the kinetic energy, that E equal to kinetic energy of mv square. The kinetic energy is of mv square plus potential energy is nothing but Coulombic force, that is K Q1 Q2 by R. And here the potential energy equal to minus K Z square by R amma. And instead of this we can take this one. So directly we'll get here of mv square minus K Z square by R. This is total energy, potential energy, kinetic energy and potential energy. Okay. And this we can write as the total energy E equal to K Z square by 2R minus K Z square by R, that equal to minus K ZE square by 2R. ఇది అర్థం కాలేదు, ఒకసారి చూడండి. ఇప్పుడు హియర్ K ZE square by R 2R, K ZE square by 2R. అమ్మా ఇక్కడ ఇది ఎట్లా వస్తుంది 2R అంటే, యాక్చువల్లీ దిస్ విల్ కమ్ హియర్ kinetic energy, the kinetic energy of mv square that equal to K ZE square by 2R. Okay, so K ZE square by 2R minus K ZE square by R kada. Now we can do here K ZE square by R is a common. ఇక్కడ ఏం తీసుకోవచ్చు, K ZE square by R. If you take common here 1 by 2 minus 1, ఎందుకంటే ఇది మొత్తం కామన్ వస్తే ఇక్కడ 1 మిగిలిపోతుంది కదమ్మా, హియర్ minus 1. So that's why that we can write as a minus 1 by 2 K ZE square by R. అంటే ఇది ఈ రెండు ఒకటే. Okay, and this is this value, substitute this R value. దీన్ని మనం ఏం చేయాలి, ఈక్వేషన్ 3లో సబ్స్టిట్యూట్ చేయాలి. సబ్స్టిట్యూట్ ఇన్ ఈక్వేషన్ 3. వేర్ ఇట్ ఈస్ ఈక్వేషన్ 3? putting the value one minute, I will explain. Putting the value R in equation 3. Amma equation 3 day before yesterday we discussed already. What is that? That R equal to n square h square by radius, n square h square by 4 pi square m K ZE square. సార్ నో, ఇది ఈక్వేషన్ నెంబర్ 3. ఇక్కడ దీన్ని సబ్స్టిట్యూట్ చేసామనుకో, ఇఫ్ యూ సబ్స్టిట్యూట్ దిస్ వన్ ఇన్ ఈక్వేషన్ నెంబర్ 3, ఆర్ వాల్యూ సబ్స్టిట్యూట్ అంటే ఇందులో ఆర్ బయటకు తీసుకొని సబ్స్టిట్యూట్ చేసినాం అనుకో అమ్మా, వాట్ వి విల్ గెట్ హియర్, here we'll get the energy of electron En, that equal to K ZE square into 4 pi square m K ZE square by 2తో మల్టిప్లై అవుతుంది. ఇక్కడ 2 ఉంది కదమ్మా, సో 2తో మల్టిప్లై అవుతే ఏమవుతుంది, 2n square and h square. Okay, here the finally putting the value of putting the value of pi and k and electron and m. So finally we'll get the energy of electron. After substituting all values, the energy of electron will get minus 13.6 into minus 13.6 into z square by n square electron volts atom. This is main formula of energy of electron. This you have to remember to calculate the problems. Okay. Now here actually the energy of an electron, that let the total energy of electron is the sum of the kinetic energy and potential energy. This is kinetic energy and this is the potential energy. And one more potential energy, instead of this we can take this one also, minus k ze square by r half mv square by half mv square minus half mv square is nothing but kinetic energy minus potential energy. Okay. Here and kinetic energy, one more they have taken, instead of half mv square k ze square by 2r. This one also kinetic energy. Okay. Now k ze square by 2r minus k ze square by r. This total value is మొత్తం ఎంత అవుతుంది? ఇది అవుతుంది minus k z square by 2r. ఎట్లా? z square by 2r minus k z square by r is minus కాదు, k z square by r. Here k z square by r is a common. అప్పుడు ఏమవుతుంది? 1 by 2 minus 1. So after simplification we'll get minus of k z square by r. అంటే ఈ 2 దీంతో మల్టిప్లై అవుతుంది కాబట్టి 2r అవుతుంది. ఓకేనా? సో ఇందులో r వాల్యూ, దిస్ r వాల్యూ r equal to ఈ r equal to తీసుకొని, this is equation number 3 we discussed in the radius of Bohr's orbits. అందులో సబ్స్టిట్యూట్ చేయాలి. ఓకేనా? సో ఏం తీసుకుంటున్నాం? ద ఎనర్జీ ఆఫ్ ఎలక్ట్రాన్ ఈక్వల్ టు k z స్క్వేర్. ఇదేం లేదమ్మా, k z స్క్వేర్ ఇక్కడ వచ్చి 4 pi స్క్వేర్ m k z స్క్వేర్ ఇంటూ వేసి కిందికి వస్తుంది. అంటే ఇక్కడ 2 ఉంటుంది ఆల్రెడీ, 2 into n square h square. After putting these all values, h value, Planck constant, electron constant, and next k constant. After putting all values, we'll get the energy of electron minus 13.6 into z square by n square. Z ante atomic number, n is a orbit number. Okay, is it clear? Okay, I will revise one more time. First in the I am revising again radius of orbits. What is the formula of that? Radius of various orbits. What is its formula? Radius of various orbits is Rn. Radius of nth orbit, that equal to 0.529 into n square by z angstroms. Is it clear? This is radius of orbit. And next, second one, velocity. Velocity of an electron. These formulas are important. I will ask these formulas. Velocity of an electron. Velocity of an electron, that V equal to 2.188 into 10 to the power of 6 z by n meter per second, or V equal to 2.188 into 10 to the power of 8 z by n centimeter per second. Okay. And next, energy of electron. What is the formula? Energy of electron. Energy of an electron What is its formula? That energy of an electron is nothing but simply we can take here En. Energy of an electron equal to minus 13.6 into Z square N square. Z square by N square. Electron volts per atom. Okay. These three formulas are very, very important. Okay, na? You can remember directly. Radius of orbit. This is the radius of orbit formula, and this is velocity of electron, and this is energy of an electron. Is it clear? And some extra points. Some extra points. In that, the first one, kinetic energy. Actually, their kinetic energy that equal to k ze square by 2r. That means here kinetic energy is inversely proportional to its radius. అంటే ఇక్కడ ఏమొస్తుంది? On increasing radius, on increasing radius, kinetic energy decreases. On increasing radius, kinetic energy decreases. Okay. And next, one more point. Potential energy. The potential energy P equal to minus K ze square by R. That means here potential energy is inversely proportional to minus 1 by R. Minus 1 by R. Minus 1 by R. Inversely proportional to minus 1 by R. That means on increasing radius, on increasing radius, potential energy increases. Potential energy increases. Why it is increases? Because of minus R. Minus and inverse. Inverse means it will come upward only. So the potential energy is directly proportional to radius. Potential energy increases. Is it clear? ఇక్కడ మైనస్ ఉందంటే డైరెక్ట్లీ ప్రపోర్షనల్ అన్నట్టే కదమ్మా. And next, energy, the total energy, that E equal to minus K ze square by 2R. So the same E is directly proportional to minus 1 by R. That means on increasing radius, on increasing radius, total energy increases. Total energy increases. On increasing radius, the total energy increases. Okay. And here the one more important formula I am giving. Energy difference between the energy difference between two energy levels. Between two energy levels. The energy difference between two energy levels that is the energy of higher order, that is En2 minus En1, that equal to minus 13.6 into Z square into 1 by N2 square minus 1 by N1 square. Okay. And I forgot to say these all are applicable for only single electron atoms. These all conditions are applicable for only single electron atoms. Okay. ఇవన్నీ కండిషన్స్ కూడా సింగిల్ ఎలక్ట్రాన్ ఆటమ్స్ కి మాత్రమే అప్లికేబుల్ అవుతాయమ్మా. These all are applicable for only single electron atoms. Example, hydrogen, helium plus and lithium plus 2, like this. Okay, na? I am removing this one, and this page is important, and that too these formulas are very very important. Radius of orbit and velocity of an electron and energy of an electron, and this is energy difference between the two energy levels. Okay. Now I will give examples. Shall I remove this page? Everyone, is it clear? Okay, fine. Now we'll go with examples. One example, listen here. The energy level for hydrogen atom. Energy level for hydrogen atom can be represented as follows. Actually, hydrogen atom, whatever it is, this is the nucleus, right? Plus charge is the nucleus, and it contains shells. This is the first shell, and second shell, and third shell, fourth shell, and next fifth shell. It will go so on. Fifth shell, sixth, and seventh shell. Okay, here this is nothing but we know that is the K, L, M, N, O, P, and Q also. Okay. How many energy levels? 1, 2, 3, 4, 5, 6. P వరకు తీసుకుందామా? No, enough for P. Okay, fine. And here this we can represent it as 1, 2, 3 also. 1, 2, 3, 4, 5, 6. Okay. And energy levels. When it comes to energy levels, and this is E1, the first energy level. This is E1, and that is means first energy level. And this is E2, second energy level. E3, E4, E5, and E6. Is it clear? Just I represented the shell side energy level sum. That's it. And we know this one already. This is the nucleus. Yes or no? This is nucleus. Okay. Now, for example, what is the energy of an electron? energy of an electron n is equal to 6 thamma. N is equal to 6. Then energy calculate cheyandi naku okasari. Energy of an electron n is equal to 6 or p shell. How we can calculate this one? By using this formula. Minus 13.6 into z square by n square electron volts. ఇప్పుడు చేయండి ఇక్కడ minus 13.6 into z square ante atomic number of hydrogen is 1 square and it is the sixth shell, so 6 square. So that means we'll get what we will get here. Minus 13.6 into 1 by 36, right? Simplify this one fast. How much you got after simplification? Make it fast, or else shall I write? Okay, right. Minus 0.377 will get, right? Okay. Minus 0.37 is nothing but we can take as a minus 0.38. Okay. So did you understand to calculate this? Because why? Because I am going to write the all values. Now the N6 or P shell, that is nothing but energy, sixth shell energy, that equal to minus 0. Minus 0.38, right? And next n is equal to 5 amma, or that is O shell. O shell ante the energy level of fifth, the energy of fifth and minus 0.54. These all are electron volts only. Next, if n is equal to 4, yes, okay. If n is equal to 4, or that is n shell, its value minus 0.84, 85 electron volts, and n is equal to 3, or m shell. Amma ivanni meer own ga calculate cheyochu. I am writing directly, meeku ide vastadi answer. E3 and minus 1.51 electron volts, and n is equal to 2, or that is L shell, and energy level is E2, and here minus 3.4 electron volts, and n is equal to 1, or that is K shell, and first energy level, and here it will get minus 13.6 electron volts. Is it clear, everyone? Now listen, these are the energy levels of energy of electrons in the different energy levels. Now the difference between E5, how can you do this one? The difference between the energy 5 to energy 4th, 5th level and 4th level amma. What is the 5th level energy here? Do this answer. Minus 0.54 amma ikkada E idi ante, here we can write E equal to the energy equal to E5 minus E4. That means here minus 0.54 minus in minus minus 0.85. Do it here minus 0.54 plus 0.85, right? Why? Because minus it minus plus here. So answer will get here 0.31 electron volts. This is the difference between two energy levels. Is it clear? అంటే డిఫరెన్సెస్ ఫైండ్ అవుట్ చేయడం వచ్చు కదా, ఇప్పుడు అర్థమైంది అనుకుంటా. Actually, first we have to calculate the energy of electron in that particular energy level, and we have to subtract this one by using this formula E equal to E2 minus, that formula is nothing but, if for example energy of an electron that equal to N2 minus N1 amma, higher energy level minus lower energy level. Is it clear how to calculate this one? For example, try to calculate this E3 minus E2, the energy of E3 minus E2. What is the answer? E3 minus E2. Send the answer fastly. Okay, wait 1 minute. What is its answer? Right, 1.89. Okay, fine. So 1.89 electron volts. Did you understand, everyone? So here you have to remember, in Bohr's model, you have to remember what you have to remember, Amma? Radius of orbit, and next velocity of an electron, and energy of an electron. Okay, these three formulas you have to remember to calculate the problems. Up to here clear, everyone? Radius of various shells, and velocity of an electron, and energy of an electron. Everyone, I am going to remove this page. We have so many problems to calculate it. Okay, we'll see. Uh, 1 minute. Shall we take class tomorrow?